Let's talk about a second example. We want to find an equation which tells us the solution of some problem, and then we will talk about how to find the root of that equation, the solution of that equation, and that's what we are doing. And it's a very, very interesting example. Let's assume that the Earth we are all living on, there is the equator of the Earth. And what do? We span a rope along this equator, tightly spanned. And now we take this rope, open it, and add 1 extra meter, and then we lift the rope at one position, and the question is, how high can we lift that rope? Okay, if you want to, then stop the video and think about what we can do. Okay, so if the rope is stretched, maximal stretched, then this is a straight line. And here at the position where the rope touches the Earth the first time, we have an angle of 90 degrees. That's a property of circles. Okay, and what do we know? If this is the radius of the Earth, then this is the length of the rope before extending by 1 meter, and this is this length plus half a meter. We extended by 1 meter and on every side half a meter extra, so it's half a meter more. And now we want to formulate an equation, and after having this equation we want to find the solution of the equation. Pythagoras, in Germany we say Pythagoras, tells us that here, having a right angle, this length squared plus this length squared is equal to this length squared. And this length is r squared, this length is rx plus a half squared, and that is equal to r plus d squared. What is r? R is the radius of the Earth, d is the height we are looking for, and x is an angle in not degree but in radians. Okay, so what do we have? We have this equation, and there are 3 letters. R is only an abbreviation of the radius of the Earth. Okay, so this is not really an unknown. It is a known. Okay, but we don't know x, this angle, and we don't know d, this height. So we have an equation and the solution we are interested in, but we have an equation and there are 2 unknowns and only 1 equation. This is not a good situation. So we need a second equation. If you have 2 unknowns, you need 2 equations. Okay, so what idea may we have? Okay, I'm asking you some suggestion. Okay, maybe you say cosine x is this length divided by that length. So r divided by r plus d. And now we have a second equation. A second equation is a good thing. If we have 2 unknowns, we need a second equation. This is the second one. We can reformulate, multiply by r plus d and divide by cosine x, and we end up here. What do we see? We have an r plus d, and this is equal to that. So r plus d can be substituted by that, and then we have no more d in the equation. We have a new equation, and one unknown, and this unknown is x. Okay, we can rearrange that equation into a equal to 0 equation. Okay, and that means that defining that function, we are looking for the root of that function. Okay, and r, as I said, is 40,000 kilometers divided by 2 pi. And if we want to work in kilometers, then this is correct. But if we want to work with meters, then we have to multiply by a factor 1,000. Okay, so is there a solution? And the truth is, yes, it is. Check our f and you see if x is 0, then the value is plus a quarter, and that's more than 0. If you push x close to pi divided by 2, 90 degrees, then you can easily see that we will have a negative function value. If x is a little less than 90 degrees, then this is a number very close to 0, a positive number very close to 0. R divided by that number is a very large number. Squaring this number, this is a very, very large number, and this is not a very, very large number. And so the sign of f will be negative in that case. And that means there is a root in between. Pi divided by 4, negative here, there must be a root because the function is a continuous one. But how can we find this solution? How can we find the solution of that equation? X is the unknown and it shows up twice, and it's impossible to eliminate one x. So ending with an equation x is impossible because we can't get rid of one x, whatever we might do. Okay, so this is a challenging equation, and we will discuss some algorithms, and applying these algorithms we will find x is equal to 0.00617664. Okay, so why is that such an horrible function f? If you plot it, it looks like that. Here on the y-axis we have very, very large numbers, and if we zoom in here, we see a straight line going up. If you plot that, you will be very surprised. That was the case for me, at least. I was very surprised, and I tried to make sense of what I see. Okay, then I had some ideas. I put that in code, and then, okay, I saw interesting things. The point is, here we have only 100 points, and here we have 100,000 points, and we are checking the interval from 0 to 0.1, and then we see a function going straight up, coming back, and then crossing the x-axis at this point. This is a point we are looking for, and this is a very, very bad function, and our algorithms will have trouble solving that. Okay, now we have the angle x, but we want to find d. So we can check our equation 1 and can solve for d, and then we get this one. And then plugging in the number, you get this answer. D is equal to 121.44 in meters. And that means you can lift the rope by 120 meters. This is a very, very astonishing answer. And the first reaction is there must be some error. It is impossible. You can't lift the rope by more than 100 meters. But but this is true, there is no error. So I talked about that in various courses, and once a student, or I think it was a female one, said, I have a different idea. Instead of the equation 2 you formulated, I prefer tangent x and tangent x equation. I will show you. Okay, where does that come from? It comes from tangent of x is that length divided by that length, rx plus a half divided by r. And we are here. And what is the advantage here? We don't have a d, there's only an x. So, okay, this is also a good choice. And checking this, you can reformulate, and this equation, or better, this function, is a much more tame function. Okay, I want to show you that. If you plot that function, you get this function. If you zoom in a little here in this, for the x-axis between 0 and 0.01, you get a curve like that, and it's a monotonic curve starting with a negative value, ending with a positive value, and here the values are between 3 times 10 to the power of -7. Okay, very small numbers, but that doesn't matter at all. But a monotonic function, and so there is a root. And this one will be a much better choice for our algorithms. That's also a very interesting thing. If you have an equation, maybe there is a better choice. Okay, and when using that, we can use the F0 command in our script. We will talk about algorithms which can be applied by F0. What does F0 do? This is the MATLAB command you, being a user, can use. And in our lecture about numerics, I want to explain to you what happens behind the curtain. What happens if you call F0, or what are possible algorithms which can be applied by F0? That's what we are doing, but there is a command, and we will understand this F0 command in the end of our script. And I tell you, there are many surprises about that F0. You will be astonished, I promise you.